Space is not as full as it looks. When you look up at the night sky, it feels crowded with stars. Billions of glowing points scattered in every direction. It gives the impression that the universe is packed solid with matter. But that picture is misleading. When astronomers zoom out far enough, the universe reveals something far stranger. There are places where almost nothing exists. Not stars, not planets, barely even galaxies. One of these places is so vast that if our galaxy were trapped inside it, humanity might have believed we were alone in the universe for most of history. No neighboring galaxies, no distant spirals glowing faintly in the sky, just darkness stretching endlessly in every direction. This region is often called the Great Nothing. And hearing about it raises unsettling questions. Is it a hole in the universe? Is it growing? Is something leaking out? Could everything, including our galaxy, eventually fall into it? To understand the truth, we need to take a step back and look at how the universe is actually built. The universe is not evenly filled with matter. On the largest possible scale, it does not resemble a smooth ocean of stars. Instead, it looks more like foam or a sponge. Dense regions are packed together in long strands and massive clusters, while enormous gaps lie in between. These gaps are known as cosmic voids, and they dominate the universe. Roughly 80% of all space consists of these vast, underpopulated regions. They are not completely empty, but compared to the rest of the cosmos, they contain almost nothing. Even our own Milky Way sits near a relatively sparse region of space. But compared to what lies farther out, our local neighborhood is still busy, because one void stands far above all others. It is known as the Boötes Void. Astronomers sometimes refer to it as the Great Nothing. The Boötes Void lies billions of light years away in the direction of the Boötes constellation. Its size alone makes it one of the most extreme structures ever discovered. It stretches roughly 330 million light years across. To truly understand that number, consider this. Light travels faster than anything in the universe. It moves at nearly 300,000 kilometers per second. Even at that unimaginable speed, it would take light 330 million years to cross the Boötes Void from one side to the other. Our entire solar system, from the Sun to the farthest reaches of the Oort cloud, is insignificant by comparison. On the scale of this void, it is less than a grain of sand. Inside this colossal region, astronomers have identified only about 60 galaxies. A region this large should normally contain thousands. Instead, it is nearly empty. This emptiness is not subtle. The Boötes Void is surrounded by massive galaxy clusters. Dense walls of matter form its boundaries, making the absence of galaxies in the center even more dramatic. It is like standing in the middle of a vast desert while towering cities rise along the horizon. If our galaxy were located deep inside this void, the history of astronomy would have unfolded very differently. For most of human civilization, the night sky would have appeared almost unchanged. We would still see stars within the Milky Way, but nothing beyond it. Early telescopes would have revealed no nearby galaxies. Even powerful instruments would struggle to detect anything outside our own. The universe would have seemed small, quiet, and isolated. It was not until the middle of the 20th century that astronomers finally detected extremely faint galaxies far beyond the Milky Way. If humanity had evolved inside the Boötes Void, that discovery might have marked the very first realization that other galaxies even existed at all. Despite how unsettling this sounds, the Boötes Void is not a cosmic threat. It is not a black hole. It is not consuming matter. It is not expanding toward us. Black holes form where enormous amounts of mass collapse into a tiny space, creating gravity so intense that not even light can escape. The Boötes Void is the opposite. It exists because there is very little matter there. Nothing is being pulled inward. In fact, billions of years ago, matter slowly flowed away from this region, leaving it underpopulated. To understand how something so empty can exist, we need to go back to the earliest moments of the universe. Shortly after the Big Bang, matter spread outward in every direction as space itself expanded. But this expansion was not perfectly smooth. Tiny random variations known as quantum fluctuations caused some regions to contain slightly more matter than others. At first, these differences were incredibly small, but gravity amplified them. Regions with a bit more matter had stronger gravitational pull. They attracted even more matter over time. As they grew denser, their gravity became stronger still. Other regions lost matter as it drifted away toward denser areas. Over billions of years, the universe slowly reshaped itself. Dense regions gradually became galaxies, clusters, and vast superclusters. Less dense regions lost more and more matter, becoming emptier over time. This is how cosmic voids were born. Galaxies never formed randomly. Gravity pulled matter into long, thin structures called filaments, stretching across vast distances and connecting clusters like highways linking major cities. Together, these filaments formed the immense structure known as the cosmic web. On the largest scale, the universe resembles a network of glowing threads surrounded by enormous empty bubbles. Galaxies gather along the threads, massive clusters form where filaments intersect, and the spaces between them slowly empty out, forming cosmic voids. Over time, smaller voids merged into larger ones. Matter flowed from regions of weaker gravity toward denser areas. The universe gradually reorganized itself, amplifying tiny differences left from the early cosmos. This slow process created enormous voids, including one of the largest ever discovered, the Boötes Void. The Boötes Void is remarkable not only for its size but for its surroundings. Massive galaxy clusters and dense filaments act like cosmic walls, enclosing a vast region of near emptiness. The contrast is extreme. Crowded regions on one side, a vast expanse where galaxies are few and far between on the other. Astronomers only discovered these giant voids in the 20th century. For centuries, telescopes provided flat views of the sky. Galaxies appeared as scattered points of light with no sense of depth. That changed with redshift surveys, which measure how fast galaxies move away as space expands. By mapping distances in 3 dimensions, astronomers revealed the universe's large-scale structure. In 1981, Robert Kirshner and his team noticed a massive region almost devoid of galaxies. At first, it seemed like an error. Repeated observations confirmed it. This was not dust or missing data. It was a genuine cosmic void. Since then, many voids have been discovered. Some are small, others immense, but few match the scale of the Boötes Void. Far from being empty and useless, voids have become powerful tools in modern cosmology. Containing so little matter, they allow scientists to study the universe in a cleaner environment. Effects that are hard to detect in crowded regions become more visible in emptier ones. One of these effects involves dark energy. Everything we see, stars, planets, gas, and galaxies, makes up only about 5% of the universe. Around 27% consists of dark matter, an invisible substance that shapes galaxies. The remaining 68% is dark energy, which drives the accelerating expansion of the universe. It pushes space outward, causing distant galaxies to move apart faster over time. Despite its dominance, scientists still do not know what dark energy actually is. Cosmic voids are highly sensitive to dark energy. As the universe expands, voids grow larger and emptier. Studying their evolution allows scientists to test different theories about this mysterious force. Voids are also ideal for studying neutrinos, tiny, nearly massless particles that rarely interact with matter. Trillions pass through every human body every second. Because voids contain minimal matter, neutrinos travel through them with little interference, revealing their influence on cosmic structure. To explore these mysteries, scientists launched the Euclid mission. Euclid maps billions of galaxies across a third of the sky, including some whose light has traveled 10 billion years. Launched in 2023, it orbits nearly 1 million miles from Earth, free from interference. Its instruments observe both visible and infrared light, detecting galaxies near and far. Over several years, Euclid will produce one of the most detailed cosmic maps ever created. Named after the ancient Greek mathematician Euclid, the mission emphasizes the importance of geometry in understanding the universe, its shape, curvature, and structure. Cosmic voids like the Boötes Void are not flaws, they are natural outcomes of cosmic evolution. The Boötes Void is not a threat. It is a reminder of how uneven, complex, and surprising the universe is. Sometimes the most important clues about reality are not found in crowded regions of stars and light, but in the deepest, quietest emptiness, where almost nothing exists.